Hello everybody, I'm Chris Littlewood. I work for a company called Filtered. We do online training in essential business skills. So we do Microsoft Excel, the other Office, the rest of the Office suite, compliance, communication, leadership management, project management, that sort of thing. But the thing that sets us apart is that we aim to teach just what you need to learn. And we mean something quite specific by that. We mean that we strip out from every individual's training the stuff that they know already and the stuff that isn't useful for the way that they want to apply the training, the way they want to use it in their work. And we do all that with an algorithm, so we can do it individually for each user on our website. And that's what I want to talk about today. It's our own experience of using algorithms and trying to draw out from that something that's maybe a little bit applicable to anyone trying to use personalized training. Because we think that this sort of training, personalized training, is going to become ubiquitous over the next few years, because it's sort of self-evident that it's more impactful if you can get specific stuff that's useful to an individual in front of them as opposed to generic one-size-fits-all training. Then it takes them less time, they're not doing irrelevant stuff, they're more engaged with it because it's more relevant to them. It's more valuable if you can pick the valuable bits that are going to make more of a difference to their work downstream. So I want to talk a little bit about that. Just before I launch into that though, please come and speak to us. We're at stand 23, which is just behind us over there. Please come and have a chat, find out a little bit more and ask some questions that occur to you. Or else, by all means, ask questions after the talk, but my email is just chris@filtered.com. Always keen to talk about things specifically or generally, so please don't hesitate to drop an email. So what I want to cover is, firstly, what I want to do is take a step away from training and talk about the use of algorithms more widely, because quite a few other online industries are further ahead than we are in training in the application of algorithms, and I feel that there's quite a lot we can learn from them. But then I want to talk about our specific experience at Filtered and what we've done, the way we've applied an algorithm to training. And then lastly, I want to try and draw from those two other sections and try and distill that down into some principles that apply generally if you want to build your own personalized training, buy some personalized training, whatever. So first of all, I want to talk about usage in usage of algorithms in other online industries. So this is just a sample to try and give an idea of the breadth of application of algorithms in online training. So we've got Shazam at the top left, which they do, of course, tune recognition. You use the app Shazam on your mobile, and you can tell what tune's playing in a bar. Amazon are in the business, of course, of predicting with an algorithm what you're going to buy from them next, what you'd most likely to buy from them. Quantopian, they do financial trading, so they have algorithms that track the markets, track indicators of the markets, and try and make money for you, spot when it's the right time to make a trade. Then we've got iOS 5 example of facial recognition, so that's simply taking an image and using the features of that image, the data in that image, to identify an individual. So they're in the business of making a prediction. It's a prediction, which individual does this face belong to? Boxcryptor, so they do cloud-based, so what they do is encrypt stuff so that you can make transfers between your computer and the cloud. They enable safe use of cloud-based services. Very famously, of course, Google have an algorithm. So they've got an algorithm in two parts, which I'll talk a little bit about in a minute. And then Newton at the top there, then that's taking a step back towards training. So they are pioneers of adaptive training, mostly in higher education and in schools. So they use an algorithm to personalize training for the user, just as we do, but with a slightly different focus. So you might ask, so what? There are lots of use of algorithms in online industries. But actually just picking on three of these, then they're doing almost exactly what we want to do with training. So what they're doing is selecting content. They're trying to get bits of content and put it in front of a user so it's relevant to that particular user. So I want to talk about these three specifically because there are really directly transferable things here that we can use. So Google, to start with, so this schematic with the big blobs is an indication of how their PageRank algorithm works. So as I said, Google's algorithm works in two parts. One half of it is about quality of sites. So irrespective of who I am as a user, they rank websites in terms of quality. And the way they do this is with this algorithm here. So just to quickly cover what's going on here. So the size of the blob is just the quality of the site as determined by the algorithm. And the arrows are links between sites. So to take the red blob first, then the reason that's large, the reason that is high quality is straightforward. It's got a lot of arrows coming into it, a lot of links from other sites. So the algorithm assumes that if you've got a lot of links to your site, that's because a lot of people think it's valuable, and so that it's a high-quality site. It's a little bit less obvious why the brown blob is so big. So that only has one arrow coming into it, but crucially, it's coming from a really high-quality site. It's coming from the red blob. And not only that, but that arrow is the only arrow coming out of the red blob. So it's like sites confer their quality on other sites, but that gets diluted. So if I link to a million other sites, they only get a millionth of my quality in that sense. So, okay, so how does this apply to training? There aren't links generally between bits of training content. But, and there aren't formal links. There aren't hyperlinks generally between our training and lynda.com's training. But what there are often is common users. And it's them that forge the links when it comes to training. They forge the links between a piece of our content, another piece of our content, and even a piece of someone else's content. So the point I want to make here is we can do exactly the same thing as the PageRank algorithm. All we need to do is capture that user data and use that as the link between the bits of content. So that's Google. Newton do pretty much that. So this is a schematic taken from Newton's website. And again, you can spot the similarity with the way that the Google algorithm is presented. So the squares are bits of training, and the links are forged by users. They're users who, so the way Newton works, more or less, is that if I do a bit of Newton's training and I'm successful with it, and then I do another bit of training and I'm successful with it, then Newton will, I forge the link. So a new user comes along, is successful with the first bit, then Newton will assume, well, they're also going to be successful with the second. I'm going to give them that. So it's just as Google does, using users as a link between bits of training and trying to get training in front of the users that's appropriate to them. So the last example from outside training I wanted to use was Amazon. So these are, what's showing here is some recommendations made to me by Amazon. So it's saying, you've just bought this item. I'd bought some microscope slides because I was giving a talk in a school. It was the only time I'd ever done that, only time I've bought such an item. But it's using that and saying immediately, this really simple recommendation, you've looked at this, other users who looked at that also looked at these other stuff. So it's saying, do you want to buy something almost exactly the same? Do you want to buy a book about microscopy? So on the face of it, it's a naively simple recommendation. But the point I want to make with this is that sometimes naively simple is fine. It might well be that the best recommendation you can make for me is that I buy something really similar to what I've just bought. I might want two of them. I might want to extend my understanding of what I've just bought. So the lesson that I would take from this is that it's easy to get lost in the sophistication of algorithms and interested in them for their own sake, but don't lose sight of what they're trying to do. If you can do it simply, which often you can, then do it simply. So this is just to summarize what I think is transferable from other industries to ours. And that's, so there's loads of other industries who've been doing this now. And so there's lots of tried and tested techniques that we can just steal. at the heart, most of them are looking for correlations between bits of content. And that's really what we need to do. And the way we do that is with students. So we need to capture our user data and track it, how they do with different bits of content. So data's at a premium. You need to be careful to capture it. And lastly, the Amazon point, that sometimes a really simple approach is the best one, can achieve what you want. So that's elsewhere. Now I want to focus a little bit on specifically how we've tried to learn from that and apply it in our own case. So this is an example of some of our training. So this is a communications, influence and teams course. So the material is a mix of text, of images, of video, of exercises, of quizzes, questions. But the thing I want to draw out here is over on the left-hand side, the little grid. So this is a course, we break our courses down into what we call modules. This is a course of around 60 modules. Each of those little squares is a module. And the color coding there is what we're talking about when we're talking about personalization and filtering. So the white squares in that grid, those are modules which we think are useful for that particular individual student. And why do we think that they're useful? We think they're useful because we've assessed that it's new stuff to them. They don't know it already. And we've also assessed that it's stuff that's useful for the way they want to apply this particular training. So they're getting, looks like roughly half the course that we're recommending that this student studies. So how do we make that deduction? So we need some data to do that. So we ask the student questions. When they start out with us, then we ask them questions about their job, about the tasks that within this field, within communication, that are really important in their work and which are less important. We ask them how confident they are with those tasks. And we ask them test-style, multiple-choice, benchmarking questions to really make sure that we've got an objective view of their current level of proficiency in the different parts of the training. And then what we do is we group them with similar users. So they've given us some answers to questions. We've got a big database of historic users who've also answered similar questions or the same questions. And we use an algorithm to spot similarities between them and those historic users. And what's more, those historic users give us feedback. So they tell us whether, in fact, the stuff that we put in front of them, the stuff that we recommended that they study, is actually useful. So we get that feedback on the site automatically for all of the users. And it's that allows us to make recommendations that are driven by data, because we can say, you're similar to these users, this is what they found useful, so you should study it, or the converse. So this one's a bit frightening, but this is saying it more or less what I've just said. So on the left-hand side, we've got a load of questions that we ask of users. We've got an algorithm in the middle that gives them some recommendations, which modules they should be studying. And then we get feedback from those users. And then that loops round. That feedback means that the algorithm can improve for the next user, and the next user, and the next user. So that's sort of how it works. I just want to show it a little bit in action. So as I said, it's making two assessments. One is the material new to the user? Do they know it already, or is it something that's new? So that's just positioning the modules on this axis. Over here, we've got a module that we think is new. On the other side, we've got one that we think the user probably already knows. And then in the middle, there's a bit of a, I was going to say gray, but yellowy orange area. And then once we've done that, then we assess the other aspect that we're interested in, whether it's actually useful. So whether they know it or not, is it useful at all? And stuff at the top is stuff that we think is highly needed by that student. And stuff along down the bottom is stuff where they don't really need it for the way they want to apply the training. And so you can see it's the top right here of this grid that we're interested in terms of putting stuff in front of the students. If things are in the top right, that'll be in their course. If they're in the bottom left, then they won't. And we draw a cutoff somewhere. So we just do a cutoff. So in this example, we have a cutoff where we say if there's a 60% chance that a particular user needs a module, well, we'll include it in that course. If there's less than that, then we'll exclude it. So I just want to show it, that's schematically how it works. I just want to show it how it works with some real data. So what this is, this little thin band at the top is a representation of our project management course. So this is a course with about 60 modules in it. And the color coding of those modules across the way is the indication of whether this is new to the student. So green means we think they know it. There isn't any red there yet. If there were, then that would mean we think it's new to them, that they don't know it. The reason there isn't any red there is that at this point, we don't know anything about this student. This is a new student to our site. They haven't answered any questions. And so then what we do is we start to ask questions of them. And we start to update our opinion as to whether they need these modules. And as we're asking questions, then we're starting to spot which historic students this student is familiar with, is similar with. And we start to see some structure here. So we're starting to see that actually, based on their filter answers, there are some things that this student clearly doesn't know. And we get down to the bottom. By the time they finish the filter questions, it takes a few minutes. Then we know how likely it is that they need each of the modules in the course based on all of the data that we've got from our historic users, and in particular, the historic users who are similar to them. And then we can populate this axis. So this is talking about the extent to which stuff is new to them. So the second half of the algorithm works in a slightly different way. When we're trying to work out whether what sort of thing is useful to the student as opposed to what their current knowledge is, then we use a clustering algorithm. And the reason we do that is that we see really quite distinct types usually in the data. So they'll tend to be, I guess there's more structure in what people need to do than in what they already know. What people already know can be more patchy. So what this is showing, each dot on this plot is a student. And this is just where they appear on the plot depends on their answers to the filter questions. So this axis is about importance of project planning. The vertical axis is about, what is it about? It's about managing performance in the project. And depending on their precise answers to filter questions, then we can position each user on this grid. Now, the color coding is just produced by a clustering algorithm. So we use a standard clustering algorithm that groups points which are locally similar. And so what we're doing there is we're grouping each user with similar users from the past. And the reason that we do that is, so when a new user comes along, we can associate them with a particular group just based on their filter answers. And then what we can do is give them a course that is reflective of what was useful, the ideal course for all of those historic users who've given us feedback. So that's how we went about this problem. So I hope you can see some of the similarities with the companies I talked about at the start, in that what we're trying to do is essentially link students to each other, and using feedback that we get from students, give them, the historic students, give them a course that is ideal, more ideal than as the data builds up. So what I'd like to do finally to sum up is to try and draw out some principles that I think apply to personalizing learning really widely. So the first one is evidence basis. So this is really the bread and butter of doing this sort of thing. So if you don't, it's basically saying, try and use your user data in order to make predictions. So you can use like an educational theory, but essentially what you're doing there is borrowing someone else's data. And the difficulty with that is the specific training can differ quite significantly. Your users might be quite different from the users that drove the development of that particular educational theory. So if you've got user data, then use it yourself and try and use that to drive your algorithms, to drive the way that you personalize, make decisions on them. So this second one is sort of a caveat to that. So what this is saying is, yes, drive your recommendations from data, but always keep in mind how they are going to land with a user. Keep the user in focus. And the reason for this is there's quite a specific thing to avoid here, which is that it's really easy with an algorithm to make recommendations which make sense in and of themselves, but when you put them together, they form an incoherent whole. So you've got to really bear in mind how to address that, how to make sure that when you add up all your recommendations, they feel coherent to the student. There are a few ways you can do that. You could do that by creating dependencies within your content, for instance. You could do that simply by making your modules of training more modular, more independent of each other. But you need to think about the way it lands as a whole. So supplementarity, what this means is just students will arrive at the training with their own strong ideas about what they need to learn and what they don't. And this is just a point made that don't throw away that insight. If they're bringing insight to the table, then it's madness to simply override that and use only the information from your algorithm to give them recommendations. So for instance, the way that we take this into account is, so while we present the student with a stripped-down course with recommended modules, then we give them access to the whole course, and they can override our decisions. They can say, actually, this module that you filtered out, I know that I want to study that and bring it back in. And that's useful for the student, because often they do know what they want to do exactly. And it's useful to us, because that helps. That's great data, because we know we've made a wrong decision, and we can take account of it in the future. This point of transparency, this is really about trust, and it's, I would say, a point of difference from algorithms like Amazon's and maybe Google's as well. And this is that when a student is accepting one of our recommendations to study our course or a piece of our course, then they are committing quite a bit of time to that activity, and they're probably doing it a little bit in the dark. It's a lot easier for me to make a spontaneous decision to reject one of Amazon's recommendations to buy, whereas in training, the student has to take a little bit of a leap of faith. And to win that trust, I think, one of the things you can do is be transparent about why the algorithm is making the decisions it's making. So this is, so an example of doing that is, well, it's about making the algorithm explicable, and making the algorithm's results not just be accurate, but feel accurate to the student. They should feel like they make sense. And I think the most important thing is that it should be clear to the student what the data is that's being used to drive the algorithm results. I think people can be unnerved by recommendations which are driven by data they didn't know they'd given. So this is about being careful and transparent in the way that you use the student data. And then lastly, acknowledge uncertainty. So this isn't a cop-out and saying it's actually quite difficult to make good recommendations. This is saying the information that you probably will know from your algorithm about how confident you are with each of its recommendations, that's really useful information for the student. Because if within the algorithm we're really confident of a recommendation, a student might well be willing to take a leap of faith and rely on our judgment. If we're only 60% confident with a recommendation, well, they might want to fall back on their own instincts as to whether it's worth investing 15 minutes in studying it. So that was all I wanted to say. As I said at the start, please come and speak to us at Stand 23. And by all means, email me or Mathilde in my team with any questions. But if there's any questions now, then I'm happy to take them. Hi. Yes, we do. So because students are generally electing to take a course, so they'll have chosen to take a communications course, then there's a quite high base of usefulness of the content in that course. So students more often will filter stuff in that we've pulled away than vice versa. But
I mean, the accuracy of the algorithm is very high, above 90%. But it's quite easy for it to be very high because people have already, they're already interested in communication. So our ambition is that we make the algorithm apply widely across the whole pool of training. Then it will have to work a lot harder to get the right, to make the right selections, because I'm not telling it what I really want to study by buying a course. I'm just anything could be presented. So. Anything else? No? Thank you very much, everybody. Thanks for your time. Really appreciate you coming to listen. And yeah, please come and speak to us. Thank you. Bye-bye. Cheers.